Did you know that there are geysers on Saturn's moon Enceladus? Hi, my name is Christopher, and the title of my science fair project is Water Temperatures and the Effects on a Geyser's Eruption Cycle. All geysers have an eruption cycle. Old Faithful in Yellowstone is the most predictable geyser with an eruption of approximately every 90 minutes. Steamboat Geyser in Yellowstone is not predictable at all. Some years there have been dozens of eruptions, while other years almost none have occurred. This is important because geysers are a model for how volcanoes erupt. Volcanoes are big and dangerous and do not erupt all that often. Geysers are small and less dangerous and erupt more often. We can deploy seismometers and magnetometers to study geyser eruptions. We can translate the information that we have gathered about geysers to better understand how volcanoes will erupt. The question is, does water temperature affect the time intervals between geyser eruptions? My hypothesis is that the results of the experiment will show that higher temperatures will cause more frequent eruptions. To test my hypothesis, I had to build a model geyser. I started with a hot plate as my base and heat source. On top of the hot plate sat an Erlenmeyer flask with over 500 milliliters of water in it to represent the underground chamber of a geyser. The flask was capped with a rubber stopper. Inserted into the stopper was a 5 millimeter glass tube protruding into the bottom of the plastic pitcher. The pitcher represents the water source for a geyser. The glass tube was inserted 3 centimeters into the base of the pitcher. Plumber's putty was used to seal the base of the pitcher around the glass tube. Water was poured into the pitcher to submerge the glass tube below 3 centimeters of water. Turning on the heat plate activates the system. Once the water in the flask reaches boiling point, the geyser would erupt. Depending on the setting, some cool water from the water source above would flow down the tubing into the flask, dropping the water below boiling point, ending the eruption. Given enough time to heat back up, the geyser would erupt again. This cycle would repeat a number of times. In order to test my hypothesis, I used heat settings 6 through 10 on the hot plate. Once I had my safety goggles on, I would set the heat setting to one of these levels and start my stopwatch. Once I observed an eruption, I noted the time in the stopwatch in my data table. Once I observed that the water had refilled the flask and the water was no longer boiling, I noted that time on the stopwatch in my data table. This continued until the water in the pitcher was no longer cool enough to stop the eruption. The mean for the duration of the eruptions at each of the heat settings was 48 seconds at heat setting 6, 173 seconds at heat setting 7, and 600 seconds at heat settings 8 through 10. This slide represents the bar graph of the mean duration of eruptions at each of the heat settings. As you can see, as the heat setting increased, the duration of the eruptions increased. At heat setting 7, I was able to observe 6 eruption cycles, and the 7th eruption stayed at a constant eruption. At heat settings 8 through 10, the model geyser stayed at a constant eruption. The mean for the time between eruptions at each of the heat settings was 248 seconds at heat setting 6, 176 seconds for heat setting 7, and 0 for heat settings 8 through 10. This slide represents the bar graph of the mean time between eruptions at each of the heat settings. As you can see, as the heat setting increased, the time between eruptions decreased. At heat settings 8 through 10, the model geyser was never able to refill the system and stayed at a constant eruption. The results of this experiment proved the hypothesis to be correct. The greater the hot plate temperature setting, the more frequent the eruptions. There are multiple things that influence how a geyser erupts, one of them being temperature. The hotter the water, the more frequent eruptions can occur. The first rubber stopper used in the flask had a central hole that was too big for the glass tubing and allowed water to escape during the eruption, but another rubber stopper with a smaller central hole that allowed the model geyser to stay pressurized during the experiment. I had to assume that my model geyser was pressurized during all trials of the experiment. For future experiments on this project, you could use a larger diameter of glass tubing. I believe that this would shorten the time of the eruptions. This would allow for a greater amount of cool water to flow into the flask quicker. Thanks for watching.